Now, having looked at the summation here, the basic definitions of I, V, delta and D, the force of interest, and the power of what we can put in this x here for e to the minus some integral of interest rates, we're going to look at the more sort of formal definitions of spot rates and forward rates. So probably the simplest concept, first of all, is the spot rate, and that is basically the average rate, whatever the rates of interest are going forward, the average rate of interest from now to some point of time in the future. So supposing we have the same rates of interest we had in the last example. Okay, so this is our sort of fundamental underlying force of interest. If you know the force of interest at every point, you're kind of in control of the whole situation. Two, three, four, 5. 1, 2, 3, 4, 5, and got 5% there, 3% there. So that goes down from 5 to 3 at time 2 and goes across there. Okay, that gives us every single piece of information we can possibly have, but then we have kind of summary pieces of information as well. So the short rate, okay, is the rate of interest right now. Okay, so the short rate is equal to 5%. That is the continuously compounding rate of interest, or in other words, the force of interest. Okay, then the instantaneous forward rate is a function of, so this is really what the instantaneous forward rate is. So it tends to be denoted by, short rate tends to be denoted by S. That instantaneous forward tends to be denoted by F. So F of at 1 year is equal to 4%. F at 1.5 years is equal to 3.5%. These are forces of interest. Once you get onto these sort of concepts, you tend to just stick to forces of interest rather than the I and the V. The V comes into contingencies more, we're dealing with mortality, stuff like that. The I is where you're dealing with fairly simple interest rate problems. Once you have sort of the instantaneous rate of interest at each point in time, you tend to be dealing with the delta concept, the force of interest. But what you look for in the question is the expression continuously compounding. Okay, but really this is about what's the difference between the short rate, the forward rate, the instantaneous forward rate, sorry. Yeah, the short rate, the instantaneous forward rate, then there's a capital F which we can use as well, which is the rate between two different points in time, which is the average rate between two different points in time. But before we do that, okay, we'll do capital S, which is the spot rate. Okay, the spot rate S is also a function of the term. Okay, so the spot rate at 3, okay, is the average rate of interest. Or more intuitively, it is the solution to e to the minus s times t is equal to the value. Okay, so the way to think about this, if I want to know what S3 is, what do I do? Okay, well, S3 should be the solution to the present value, okay, of £1 at t equals 3. Okay, in the sense that e to the minus 3 times s of 3 should equal e to the minus integral between 0 and 3, the actual force of interest dt. Okay, so this is strictly how, the point about this is the strict definition. With every the force of interest at every single instantaneous point of time, we can calculate exactly what the present value is. But sometimes we just want to know what the sort of basic discount rate is over that period of time, in which case we assume that the interest rate is constant and we multiply by the time. Okay, so it's just now a matter of solving this. And if you think about it, I don't need to do this whole expression. I can just take logs of both sides. So what I get is s of 3 times 3 is equal to integral between 0 and 3 delta t dt. Okay, so this is really how to think of it. This is the true value of £1 in 3 years' time with this fully described function of the force of interest. But my definition of the spot rate, okay, is essentially that is the single rate of interest that will give me that same value. If I think about it like that, okay, then I can just naturally derive this situation here, okay, and that's going to be 0 to 2 of 0.05 minus 0.01 dt plus 2 to 3 of 0.03 dt, which is equal to 0.05 t minus 0.005 t squared between 2 and 0 plus 0.03 t between 3 and 2, okay, etc, etc. Don't need to do the whole calculation. You can see what's happening there, and I'll get eventually what S3 is, and S3 will be something broadly in line with the average across here. So it'll be about 3.67%, because it's the average rate of interest between 0 and 3. Okay, so that is the spot rate of interest. So we've got the short rate, okay, which is the instantaneous rate right now, which is the 5%. We've got the spot rate at any given term, which is the average rate of interest up to that point. We've got the instantaneous forward rate, which is literally the value on the curve. Okay, so another way of thinking about, so you can think of this as the graph of f of t as well as the force of interest. And then we've got the longer term forward rate, the capital F, which gives us, which we have between two different terms. So really, if you think of the spot rate as being the average rate of interest between 0 and a particular term, then the capital F is the average rate of interest between two particular terms. So in this case, if I want f of 3,4, okay, then how I'm going to work that out is I'm going to say e to the minus f of 3,4 times 4 minus 3, okay, is equal to e to the minus 3, 4 delta t dt. Okay, because I'm assuming that there's a constant. If that was a constant, this would integrate to f times t. Okay, this would integrate to f times t2 minus t1 effectively. Okay, so if I solve that, in this case, I'm going to get f of 3,4 is simply equal to, well, it's 3% for that whole period then. Okay. But if it's variable over that period, if I was doing between 1 and 3, I would get something else because the interest rate is coming down from 5 to 3 over that period. So those are my different rates of interest. Short rate, which is the immediate rate of interest right now, equivalent to base rates in sort of practical terms. Spot rate, which is the average rate of interest to a given term. The small f forward rate, the instantaneous forward rate, which is the pure force of interest at a particular point in the future. And then the capital F, which is the average forward rate over a particular time in the future. This is probably the least significant of them. Okay, I think it's the interaction between the instantaneous forward rates and the spot rate that is key. So there's one sort of relationship to really sort of get your head round. It's this one here. This is kind of the key thing here. Remember, this is going back to the concept of e to the minus whatever you put in there. You just integrate the discount rate and it sorts everything out. Okay, and if you want to equate that to an average rate of interest, you just equate it to the average rate of interest. So that is, let's say, the 4 different ways of looking at forward rates of interest.